So we are going to continue on with chapter 13. For most intents and purposes, this is it. I think I've been able to squeeze most of this into 2 days, which will give us a little more time to review. I am going to sprinkle in some of this in the review, so that way we can do that. Now, I was informed on Friday that we have to move our final up.
What? Does that mean
Yeah, so instead of it being on Friday of that week, which I believe was the 21st, it's going to be on the Wednesday, the 19th. Okay? I don't have a choice in the matter.
I thought B-Day was the 20th.
Anybody remember what it is?
No, I'm pretty sure it's a...
Okay, so whatever day it was, it's the class period before. So say it. So it's the 18th in this class? Okay, whatever. That came down from above me, so we don't have a choice. So let's get rolling here. It is 5-4. This is...
the 18th for B-Day?
Yes. I don't know. That's what you said, right, Higley? Yeah. Okay. So this is Ken 11:10, chapter 13, day 2. And our objective is to be able to better understand right after I get a new pen. Woo! That's all I got left. Hopefully I can make it through the rest of the year. So to be able to better understand the nature of alkenes. Alrighty, so we're going to continue on basically where we left off last time. If you recall at the end, we talked about two things. Anybody remember what they were?
Halogenation.
We talked about halogenation and hydrogenation. Okay, now, one of those required a what? Catalyst, right? What did catalysts do again? But they speed it up by lowering the activation energy, right? Now today we're going to talk about two more. One of them is hydration. Okay? Well, what does it mean to hydrate something? Add water. So we're going to add water, and this also requires a catalyst, and that catalyst is H2SO4. Now, I'm going to beg of you not to let me down like my 6th period did. Okay? Don't be the Browns. What is that?
Something on a pink sheet?
Nobody knows what this is. I've made multiple jokes about it. It's the baddest acid. I appreciate that. You knew part of it. Anybody remember what that was? Nobody? It is the baddest acid on the block. It was sulfuric acid, right? Okay. Now, hydration follows what is known as Markovnikov's rule. Okay. Markovnikov's rule states that the rich get richer. Now, I'll explain what that means as far as hydration goes. Now, what you're going to do is you're going to basically take an alkene. Okay? You're going to add water to that in the presence of H2SO4, and you're going to get out a what? And we know what happens when I add water to an alkene, what I can make? Sometimes in the backwoods of West Virginia, I can make an alcohol. You're going to get out an alcohol. Get it? The back.
Yeah.
Only one of you got that reference?
No.
Probably a good choice. West Virginia. That's probably a pretty good. Yeah? Yeah. Alrighty. Now, this is what happens. Let's say I take a simple alkene that looks like this. Okay, and I'm going to draw it complete just so we can understand what's going on here, right? And I'm going to add H2O. Now, H2O is going to do what all those other things do, and it's going to do what? It's going to separate. Now, please do not say that it separates into H2 and O. Okay, what's this going to break up into? It's going to break up into H positives and OH negatives, right? Now, the charges doesn't matter for where we're at. It's really just an H and an OH, okay? Because we're not going to worry about the charges. Now, in the presence of acid, this double bond breaks. And it's like a gate. They kind of open up. And this is going to form a bond here. This is going to form a bond there. Now, looking at Markovnikov's rule, which states that the rich get richer, what do you think that applies to right here? What? So what do you mean?
So like the C on the right has two H's and the one on the left only has one. So the one on the right is going to be the one that gains the H.
Exactly. This gets the H. This one gets the OH. And that's how the rich get richer. If I already have more H's, I get the H. If I have fewer H's, I get whatever else it is. Okay? And it's pretty straightforward. Just remember, hydration, water, and sulfuric acid. I'm always going to get out an alcohol, which means I'm going to have an OH in there somewhere, which will also mean that this will now do what? It'll now hydrogen bond. Okay? Alrighty, now, let's say I did this. Let's go raisy handy here. I want to know what I'm going to get out. What am I going to get out? And I want, let's go 6 hands. 6 hands for what this is going to produce. Good to be back, Wiser.
Yeah?
Yeah.
It's pretty nice.
Yeah. Going on quarantine makes you realize how much you actually enjoy school, doesn't it?
Seeing people, but yeah.
Oh, it's more just seeing people, not going to school,
Yeah.
not seeing your favorite teacher.
I like my B days a lot better than my A days.
Well, that's probably because he's in my class on B days, right?
Yeah. That's the classes I taught. So.
So I have 1, 2, 3, 3 more, 4, dos más. Nobody? Am I not going to get 2 more? Wow. People, this isn't that hard. Okay, let's go on. Who was 4?
Yeah.
Okay, Oliver, what'd you do?
You wanted the skeleton structure.
Yeah, that's fine.
Okay, so basically draw the same thing without the double bond.
Okay.
And then add a bond on the very end one.
So right here?
Very end C.
What?
C, the very end.
Oh, this one?
Yeah, that one.
Okay.
And then on the second one.
Here? What goes where?
And then the H goes on the one with 3.
So this is the H.
That's the OH.
That's the OH. So my OH goes there and my H goes up here. Right?
She's close.
She's close. Well, look at it. This is what I do. Okay? This is what I do. I come up here and I say, well, I'm going to finish this. So I'm going to put an H there, right? Now, does that have 4 bonds?
Yeah.
That has 4 bonds, right? How many H's does this one have?
1.
How many does that one have?
0.
0, right? Well, this one already has 1, because this is now gone. That's where my H is going. That's where my OH is going. Does that make sense, Oliver? Now, here's a question from the last test. What is the degree of that carbon?
Third. It's a tertiary.
Why is it a 3 degree and not a 4 degree?
The other one's bonded to one.
Yeah, it's only carbon bonds. I think that exact diagram was on the test. And most of you put 4 degree because you counted that O bond as one of them. It's only carbon bonds. Okay? Alrighty, so from there we're going to talk about,
So can you classify the carbons if it's like a double bond? Like, or does that even not?
we don't.
Okay.
Yeah, I guess you could, but we don't. I've never seen a question like that.
It wouldn't
But you
count
could.
as a carbon bond.
Yeah, it would still technically have 2. Okay. All right, next thing we're going to talk about is hydrohalogenation, which consists of what? What makes something a hydrohalogen?
Water, yeah.
Close. It has hydrogen and a halogen. So we're talking like HCl or HBr. These are the two most common. Okay, hydrogen bromide or hydrogen chloride, right? Now, again, I'm going to take an alkene. Now understand, this does not apply to benzene rings. Okay, it does not apply to benzene rings. This is an alkene, and I'm going to add to it HCl. Okay? Now, why do I not need a catalyst here? Why don't I need like an H2SO4 or something? Well, because when I put this in water, it already becomes an acid. Okay? Now, again, because these are different, I'm going to follow what? Anybody know? Because what are these going to break up into? An H and a Cl, right? Well, what does that look a lot like? Yeah, hydration, right? Which means I'm going to obey. Yeah, I'm going to still obey Markovnikov's rule again. So, let's say I take this. I take this and I'm going to add HCl to that. Okay? Now, again, it's probably easier to go back and say, okay, which one has the most H's right now? Well, how many H's does this carbon have? It has 1 right there. This carbon has 0 because they're all branches, right? So, what's going to happen here? Well, when this breaks up into H and Cl, which one's going where? Yeah, where the H is, I'm going to put the other H. Where there's no H's, I'm going to put the Cl in. Okay? And in that sense, hydrohalogenation is a lot like hydration. Okay? No catalyst because I've already got an acid, and just put them in there. Okay? Now, while I'm at that, there are a couple of things I've noticed that we don't quite seem to have 100% down. If I have an alkane, an alkene, and an alkyne, what's the formula for an alkane? Anybody remember?
It's
2x plus 2.
C,
And then like
2x.
subscript X
X,
and H subscript 2X plus 2.
right? We knew that one, right?
Yeah.
And then we have CX and we had H
2x.
2X because the ends were gone, right? What about an alkyne? Yeah, then it's H2X minus 2. Isn't that... Did you do the Learn Smarts?
Maybe.
I think this is right off one of the Learn Smarts, isn't it? Right? I'm pretty sure it looked just like that, didn't it, Chance? Okay. Alrighty. Now, a couple of other things. Constitutional isomers. That's what we did last chapter, right? We called them mainly just isomers. And what did they have to have? Same formula, different structure, right? Structure, arrangement, whatever you... Inevitably, though, that made them have a different what? Not just shape, but an entirely different name, right? Now, if I look at stereoisomers, how is that different? Anybody know? Close.
They're the same, like, base name,
Exactly. The only thing that changes is what?
the system.
Yeah, cis and trans. So make sure you understand that. If it's a constitutional isomer, it will have an entirely different name because it's bonded together differently, right? But if it's a stereoisomer, it is still technically bonded together in the same way. It's just when I get to that double bond, in cis they're both going where? Same, either both up or both down. But in a stereoisomer, then they're going opposite. The only thing that will change is out in front. One will say cis whatever, the other will say trans whatever, and the whatever is going to be the same. Do we understand that little nuance right there? Alrighty, now, a couple of other things we need to talk about that actually kind of correlate to last time as well. All things equal. All things equal. The longer the chain, the what? Anybody know how to finish that? The higher the boiling point, right? Now, that doesn't apply if I'm going to look at how many what it has, how many branches. Okay, but everything else is the same. Let's say they're all just linear. They're all just regular backbone molecules, right? If I've got something with 70 carbons in it, and I've got something with 7 carbons in it, right? Obviously, the one with 70 carbons is going to have a higher boiling point, right? Now, if that's not the case, then I look at the number of branches. Okay? And then it becomes the fewer the branches, the higher the boiling point. Yes?
How long the branches do I matter? Not
It does on a molecular level, but for what we're talking about, it does not. It doesn't matter. A branch is a branch is a branch. Okay? Alrighty, now, another thing straight off of the Learn Smarts is OMP. Okay, does anybody know what they refer to? Nobody? This is kind of a different way to write things. Okay? O stands for ortho. So I got a benzene ring and I've got 2 branches like that. That's what's called ortho. Ortho means next to. Okay? Then I've got M is meta. Okay? Meta looks like this. This is meta. Okay? And they'll abbreviate it O, M, and P. Or they'll write ortho meta. Or para, right? Meta means there is 1 space in between them. And obviously you have para. What do you think para means? But they are on... Yeah, para is opposite. Now, I just got observed by my professor at the university. And when I taught this, I forgot to put my benzene. I forgot to put my double bonds in. But that's not... She came up here, and she has a little way to teach this. Where she says, ortho is like when you go to the orthodontist. Where's the orthodontist at when he's working on you? He's like right here, right? Okay. And then para, I didn't understand her para analogy. But I don't know. I think you should just know it. I don't think it's overly complicated. Just know para is opposite, ortho's next to, meta's in the middle.
And this is only for benzene rings.
Only applies to benzene rings. Okay? What were you saying?
I just go with just me remembering.
Yeah, yeah. So like a good example of this would be this. Okay, so let's say I did this. Okay. Let's say I did this. Okay. Now, this would have been, anybody know what that would be? Like what its name would be? 1, comma, 3,
Dimethyl
dash,
dimethyl.
oh, what, that's not. No, what is that?
Dichloro.
Dichloro. Now, what is this? Yeah, it's benzene. Well, instead of it being 1, 3 dash dichlorobenzene, they would call this M dichlorobenzene. Or they will literally write meta dichlorobenzene. And all three of them are technically correct. Okay? So, I don't know. They're just, I know there's questions on the test. You just need to know. Just a different way of doing the same thing. Okay? I could see using this one. Why? Shorter. We all like shortcuts. Right? But, I mean, meta, I don't know that that's any easier than writing 1, 3, is it? You know?
Reach over to your numbers.
What?
You don't want to reach over to like your numbers.
I guess. I don't know. I don't care. I just know that they're going to ask you about OM and P. Okay? Now, with that, you need to talk about, you need to know these three. And I don't know if you want to write these down or if you want to memorize them, but these harken back to, remember those tables in either 11 or 12 that I told you to know? That had like the thiols and the amines and the aldehydes and the ketones and the esters and the ethers. You guys remember them, right?
Yeah.
This is along those lines. These are things you just need to know. There's 3 of them, okay? And all these are given names for certain compounds. Now, if I have, and remember this is only for benzenes, if I have a benzene ring that's got a methyl group on it, because now it's just a methyl branch, right? This would be 1-methylbenzene, right? It has a given name called toluene. Okay? This one has an NH2 group on it, which back last chapter would make this a what? And remember what they made them when we put that NH2 on it? An amine, right? In here it's called aniline, which I was told is really aniline. I've called it aniline for my 50 years. Well, I've probably only been doing this for 35 of them, but you know what I'm saying, right? She says an aniline. Okay, I've always said an aniline. I don't care. Okay, aniline. This is called phenol. And these are the 3 main ones that you just need to know what they're called. Okay? Now, anybody recognize this word phenol?
Yes.
Yeah?
But I don't know what.
You don't know where? Anybody in here ever seen the movie Unstoppable? It's about one of the Chris's and Denzel Washington. It's about a freight train.
Oh, yeah.
Okay?
It's the chemicals and like that.
Yeah, this is the chemical. The chemical that train's hauling is called molten phenol, which simply means it's liquid phenol. Well, just looking at that, what do you know about phenol?
It's flammable
Why?
because it's the alcohol
because it's an alcohol, right? I make that an alcohol. I know alcohol's flammable, right? So that train wrecks, and they've got like 12 cars of this stuff. That's going to be a big bang with a big fire with lots of running and screaming, right? So, yeah. So that movie was, somewhat factual in that aspect, okay? Now, what they will do is they literally, you need to know them. Like, you need to know them.
So they're gonna be on the test.
If you get my drift. Okay? Now, they don't do a lot with them, but you need to know them. Now, there's one other type of addition reaction they want you to know, and that is if I take benzene, okay, and I add to it Cl2. Now, this harkens back to something from last chapter. Okay, and this only applies if this is a benzene. Okay, now, what happens is if I take benzene and I add chlorine to it, this would be what's called chlorination. Okay, and this is really the only application of this. Now, I take my benzene ring. Now, and I add my Cl2 to it. This goes back to what we did last chapter. Okay, so remember how we did this last chapter? Not this chapter, where I break that double bond, how I did this last chapter. Which is probably where it would have been a better place to teach this.
Take out an H.
Yeah, I simply take, and that breaks up, and I replace, McConkey, what?
An H.
Yeah, I simply replace one of the H's with a chlorine. Okay, that's how they chlorinate things. I think, let me look. I think it only works with chlorine. I don't think it works, because what else would be a good candidate right there? Bromine, but I don't think it works with bromine. I think it's just chlorine. And then I forgot, it also requires FeCl3. And obviously that is a what? A catalyst, which do what? Lower the activation energy. They speed it up by lowering the activation energy. Okay? And that is just an example of that. Okay? Now, yeah, it just replaces, this just replaces an H. That's why I think it's more like what we did last chapter than what we've done this chapter. Because this chapter, we've broken that double bond. Here, did I break any of those double bonds? No, so I'm not putting them both in there. I'm just replacing an H, okay? Alrighty, now, from there, we have got to talk about, and this would be called chlorobenzene. Okay? Which, why wouldn't I use a number there? It's on the one, right? I'm trying to think. Yeah. And I know I have to start on one, so that's what it's going to do. Alright, now, who knows what this word means? Who knows what a polymer is? Say it louder. They're chains. They're chains of what?
Carbons.
Not just carbons. They can be other things. Anybody know what poly means? Many. So many. Mer is, I refer to it as a unit. So polymerization is what happens. It's called polymerization. And when I was in high school, we did a really cool polymerization reaction where you took, you made nylon, right? You took two chemicals and you dumped them together. Then you stuck a glass stirring rod in there and kind of fished a strand out. You started to roll it. And it literally rolled up just like thread would on a roll or on a spindle. And you could literally roll it for hours And he would just keep rolling this little tiny filament that looked just like spider's web out of this beaker, right? What you were doing is you were simply creating a polymer, right? Polymers are created by linking what? Anybody know how you create a polymer? By linking, nobody? Monomers together. Okay? And it's actually really quite simple. This is what happens. I'm just going to draw you a basic example of what goes on here. And then there it is. So let's say I take just a common monomer. Now these are all going to create, they'll all contain a double bond. Okay. So let's say I've got this. This is my monomer. Okay. This is my monomer. So if I want to create a polymer here, what's going to happen is, for lack of a better explanation, this double bond is going to break. Okay, it's going to break. Well, that's going to require that carbon to do what? Make another bond, right? So basically it's like a gate. This side opens up and creates a bond out here. This side opens up and creates a bond out there, right? So this is going to open up and come over here. This is going to open up and come over there, right? When it does that, it's going to create a what? What does every polymer contain a whole bunch of? Yeah, but it's a repeating what? Pattern. It's a pattern of a whole bunch of these just linked together, okay? So what they'll do is they'll say, okay, I'm starting over here, and then I'm simply going to have this pattern do what? Repeat itself. So it's going to go carbon, 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 right? 2, 4, 6, and I'm going to go Cl, H, Cl, H, Cl, H, H, Br, H, Br, H, Br, like that. And then it'd be there. It'd have another, and then it'd say, okay, I'm going to break it there, right? This is merely an example of 3 what? See how I've got 3 monomers here? I've got that one. I've got 3 monomers that have created now one big polymer, right? Now, what's going to happen, and this is probably the best thing that my cooperating professor did for me in my last class, is she presented this in a different way that I don't know that I would have thought of. Now, it goes back to something we did last chapter. If you remember last chapter, we were doing isomers, and I drew this, right? I drew this diagram up, right? And initially, what did everybody think that was? An isomer, right? But then we realized what? They're the same thing, just written the other way, okay? So looking at this, it is easy to see that is one of my monomers, right? She said, but what if someone saw that? Would that still qualify as a monomer? Yeah, because technically they're the exact same thing. I'm just looking at it from the other side. And what she pointed out is that, remember, this is a multiple choice test. They might not give you the answer exactly like it looks. So maybe I might have to mentally do what? Flip it to make sure it's the same one. And I don't know that I would have thought of that, but it makes a lot of sense. Okay? That's, I think, easy. If they give me that, it might not be as easy because it doesn't look the exact same, but is it really the same thing? Yeah, it is. So you just kind of keep that in the back of your mind. I don't know that they, the one, I think there's one of each. Here's the monomer. Which polymer does it create? Break the double bonds, form it up, right? If it's a polymer, which monomer does it create, I think it's a little more difficult. What do you think is missed every time, or missed the most on that question where I'm going from a polymer back to a monomer? Anybody remember? Anybody think they know what the answer is? Yeah, they always forget. They'll get the right unit. They'll get this right, but they'll forget that that's now got to have a double bond because it's a double bond that breaks, creates it. So just remember, if I'm going from poly back to mono, make sure I get that double bond in there between those. And remember, that double bond will only be between carbons. Because a lot of, like I remember, if it was last year, the year before, kid had drawn it up and put the double bond between the carbon and the chloride. Well, chlorides don't make double bonds, right? They have a valence of 7. So just some little things to think about there. Okay? And I think... There we go. I think that's everything I had written down. I forgot to put phenol number. That's everything. I talked about everything on there, haven't I?
Yeah.
Alrighty, now, based upon that, we're going to start the review next time, which will still give us 4 days. And then what I will do is I will sprinkle in a little bit of 13 as we go. We'll probably name an alkene every day. Or, maybe I'll give you a name and ask you to draw an alkene. We'll do a little shorthand. Because I really thought that shorthand, when we covered that in 12, helped us a lot on the test. Because there was so many shorthands. There are a few shorthands on this test. Or not shorthands. What am I meaning? Condensed. Yeah. Questions? I taught that so well. No one has a question. What'd you say, McConkey?
I said accurate.
Accurate. Oh, man. Okay. Time is yours. I would use it wisely.